Geometry lesson on translation. That is lesson 2.1. Okay, guys, this is a warm up. Do me a huge favor, guys. Pause this video and work on this problem. And when you're finished, start to play. Okay, guys, I'm going to assume that you finished it. And here is the answer for this. Number 5, answer is no. Number 6, they're the same size. And here is the specifics. Instead of just giving the answer, you should provide some sort of reason. Okay. Number 5, answer is no because of the following reasons. To be more specific, the answer should be either quadrant 1, or it's either that or it's a quadrant 4. Because here's what's happening. Scenario number 1, if you have a point over here, what could have happened, you could down just a little bit, turn right. No matter how far you go, that's quadrant 1. The second possibility is that if you start with quadrant 1, you go far enough down to go past the x-axis and you take a right, then the answer will be in quadrant 4. Okay, so that's the reason why it's not. Number 6, that they're the same size, it's because the keyword over here is translation, up and left, is that translation, by definition, we mentioned that in an earlier lesson, translation is a rigid transformation. And the word rigid implies that the size and the shape it remains the same. Okay. There you go. Okay. All right. So try to provide a little bit more context instead of just yes or no. Okay. Example 1. Let us explore this. So we have an image of ABC right here, guys, right? And we're trying to translate it along the vector. This is known as we would say vector V. We generally put like a half of a arrow, but I'm still trying to figure out how to type in half arrow into the math equation editor. Okay. All right, guys. This is from the textbook, so they figured it out, but I have not yet. I'll figure it out. So what that means is that you want to translate that image triangle ABC along the vector V, and all you gotta do is actually to do that for all the vertices. So for example, in our case, the V is like 1, 2, 3, 4 horizontally, and you go up twice this way, right? So you basically go 1, 2, 3, 4, 1, 2. You go this way. Okay. So what I'm going to do is perhaps, let's go with this color, and hopefully that's big enough, okay? So I want to mimic that right there, okay? Oopsie. So, what just happened? All right, let's try that again. So I have this thing right here, guys. So what I'm going to do is I'm going to copy this. I'm going to paste it couple times, and if I move this point over here, and let's say if I move that right there, and I move that right there, okay. Sometimes I have an advantage of using this built-in system. So when you do that, you go, I'm still gonna count 1, 2, 3, 4, 1, 2. So that's A prime. 1, 2, 3, 4, 1, 2. Just making sure. B prime. 1, 2, 3, 4, 1, 2. That is a C prime. And you can sort of connect it this way, right? So now we have translated the original picture right there along this vector, and you do that with every point, and you get this image, right? And I'm going to do this one a little bit quicker. Okay, let me just go with a slightly different color now. So I'm going to do this right here, like that. And that one's slightly off, actually. Let me just There you go. I think that's about the right size. There you go. Oops. All right. I'm going to copy that. I'm going to paste it, and then I'm going to do it along the B. I'm going to do that along the A, and I'm going to do that along the C, and I'm going to do that along D. So when you do that, you should end up with over here a prime that is a B prime. So it goes like this, right? And this is right here is a D prime, and that right there is a C prime. And if you connect those points like this, and that's the shape that we get. Right? Perhaps I should do it a little thicker. There you go. Right? All right. So now it's your turn to do the you're gonna have to do the example on your own. So let me just give you the official sort of note from the textbook. So this is a very convenient way of expressing the vector right here, guys, right? The translation is a transformation along a vector such that segment joining the point and its image. So for example, point P to P prime. Point B will be a point and B prime will be the image of the point B. Has the same length as the vector and is parallel to the vector. So going back to the previous question over here, guys, if I look at every vector that I have, see this right here? They're all equal and they're parallel, right? Over here, 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 and here. So if that's one of the ways to see if you did it correctly. Okay, guys? All right, why don't you finish copying that down? And for example, BB prime, right, is a line segment that has the same length and is parallel to the V. So this one over here is same length as that, and they're parallel. So if you do to CC prime and AA prime, it will all be the same length, and they're all going to be parallel. Okay, so why don't you go ahead and try this and see what you get. Please pause the video. Okay, guys, I'm going to assume that you have done so already. If not, please pause the video, and when you're ready, play the video. And the answer to that is this. So when you go same length over here as this, right? Look at that, they're all the same length and parallel. So the triangle ABC, when it gets translated this way, becomes that one, A prime, B prime, and C prime. That's the new location. Okay. All right, guys. So let's move on to the specifics of this, right? So we're gonna learn some rules for translation on a coordinate plane, and this will harken back to your Algebra 1 material, right? Yeah, they're very interrelated. Geometry is not entirely separate from algebra, or vice versa. There's an element of algebra in geometry, and there's an element of geometry in algebra courses that we take. Technically, anytime you have a figure, it's geometry, right? So the first one is translation A to the right. So what you do is, in terms of coordinate, you would add A to the Y coordinate, right? Well, by the way, when you have this, it's a vector notation, right? It's not a location, it is how far you're going, right? And then translation to the left, A would be simply subtract on a Y coordinate. And you guessed it, when you go B units up, we're adding to the Y coordinate. And similarly, when you're going down, you're actually subtracting from the Y coordinate. All right, guys? All right. All right, looking at this example right here, guys. When we have a vector, what that means is that to get a image, right, what you do is, if you have initial points, because that, when I put a parenthesis over you guys, that's actually a coordinate. And this is telling you how much you're adding to the y, so that represents the change in x, and that represents the change in y. So the new coordinate point will be x plus the change in x, and y plus the change in y. So in this particular case, xy becomes x plus 4 and y plus 6. Sounds good? All right, guys. So the pre-image is let's call this A, B, and C. A, B, and C. That'd be -2, 1, and -3, 2, -1, -2. So how do I find the A prime, B prime, C prime? So to the -2, we're adding 4, and to the 1, we're adding 6. And that will give you 2, 7. How about B prime? So if you could do this, for fun, try to pause the video, see if you could get ahead of me. Apply the same idea. So for example, you get -1 and -2. What do you do to the x and the y? I add 4 to the x, add 6 to the y. And when you do the arithmetics, it should give you these values, right? So let's see what happened. This is 4 and a 6, right here, guys. So for me to get 4 and a 6, I would literally go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I will go from here to here like this, right? And that would be the what do you call that thing? The vector. So I am actually going to apply that to the point A. Oopsie. There you go. And I'm going to apply to that C right there. And I'm going to apply to that B right here. So when you do that, so if I do it geometrically, you will literally count 1, 2, 3, 4, 1, 2, oopsie, you can't see that, sorry about that. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So that's the point that I'm going to get, right? So I'm going to get this point, that would be C prime, that would be B prime, and then A prime. You could count them one at a time. But when I drew it along the way, they look like they're the same length and they're all parallel to each other. And I simply connect them. And then I just did this using the method that we did earlier, right? Let me just change that green. I think it shows up better. See this right here, guys? But let's confirm if we did that. Can we confirm that against the algebraic way of doing that? Let's look at A prime. That is 2 and 7. That is correct. B prime, I got 3 and 4. That is correct. C, I got 1 and 4. So if you could do both of them and they sort of like come up with a consistent answer, then you know you did it correctly. So it's a good idea to check your algebra work geometrically and your geometric work algebraically. And when you're consistent, you know you did a good job. Okay? All right, guys. So next page is your turn. So why don't you go ahead and try to do that on your own. Pause the video. Okay. If you do that correctly, the answer should be something like this, guys. So in this case, it's 4, -1. So let me have a different color there. So I will go 1, 2, 3, 4, 1. So that would be my vector, wouldn't it? There you go. And if I copy that, and if I move it around, yep, they match, right? What if I did that here? Because we're using the same vectors, right? That matches, and that matches. Like I would actually, if I did it in physical class, I'll actually use a ruler, right? And just go from there. Right? It's about the same. Okay. All right, guys. That concludes the lesson on 2.1. And if you have any questions, we'll talk about it in class. So make sure that you aggregate your questions together and let me know for the class, and we'll go over it. Okay. All right, guys. Have a good night.